Imagine an ordinary morning. You wake up, enjoy your coffee, and then walk out to the garage. Before heading to work, you plug in your electric car. Just 15 minutes later, about the time it takes to finish reading the newspaper, your car is fully charged. You then drive 500 miles without stopping once. There's no fear of running out of battery, no concern about the vehicle losing value after a few years. Even after 15 years of use, the battery still performs almost like new. It may sound like science fiction, but it isn't. This is the future Tesla claims it is working to make a reality, and not just as a concept or a promise. For years, many people believed that traditional lithium-ion batteries represented the limit of electric vehicle technology. The assumption was that battery chemistry had nearly reached its peak and that any major breakthrough would still be decades away. However, developments are happening much faster than expected. In early 2025, Tesla quietly introduced a series of technical advancements that industry analysts believe could become the most significant turning point in electric vehicle battery history since the first Tesla Model S hit the roads in 2012. This isn't a minor upgrade or a routine improvement. It represents an entirely new approach to solving battery challenges, from materials and cell design to manufacturing methods. Meanwhile, across the Pacific, BYD, the Chinese automaker that has outpaced Tesla in electric vehicle sales for several consecutive quarters, found itself facing a competitor that was no longer simply keeping up, but potentially moving ahead with a completely different kind of innovation. So what makes Tesla's new battery technology so important that the entire automotive industry is paying attention? Why is BYD, long considered one of the strongest players in the global EV market, feeling pressure from this development? And could this truly be the breakthrough that transforms the future of transportation? Or is it another example of Elon Musk making promises that engineering may struggle to fulfill? Before diving deeper, if you enjoy detailed technology and electric vehicle analysis, consider subscribing and turning on notifications. The changes coming to this industry over the next few years could be some of the most significant we've ever seen. Why the battery industry needs a revolution. To understand why Tesla's new technology is generating so much excitement, it's important to look at the broader state of the electric vehicle battery industry. Electric vehicle adoption has grown at an extraordinary pace. Global EV sales rose from fewer than 1 million vehicles in 2015 to more than 14 million in 2023. Despite this impressive growth, several major challenges remain unresolved. The first challenge is driving range. Although modern EVs can travel much farther than earlier models, many consumers still experience what is known as range anxiety, the fear of running out of battery power before reaching a charging station. For drivers living in suburban or rural areas, where daily travel distances can be significant and charging infrastructure remains limited, this concern is very real. The second challenge is charging speed. Fast charging technology has improved considerably, but even the most advanced systems typically require 20 to 30 minutes to charge a battery from 20% to 80%. Compared to the 5 minutes it takes to refuel a gasoline vehicle, that remains a noticeable disadvantage. The third challenge is battery degradation. While it receives less attention than range or charging time, it is equally important. After 8 to 10 years of use, many EV batteries can lose 20% to 30% of their original capacity. This reduction affects not only driving range, but also resale value, an important consideration for consumers who are accustomed to gasoline vehicles maintaining their value over long periods. The fourth challenge is cost. Batteries account for roughly 30% to 40% of an electric vehicle's total manufacturing cost. For EVs to compete directly with gasoline-powered cars in the affordable mid-range market, particularly vehicles priced below $35,000, battery costs must fall significantly. Despite years of research and investment, the industry has not yet achieved that goal on a sustainable scale. These four challenges, range, charging speed, battery, lifespan, and cost, are the focus of countless research programs around the world. Thousands of scientists, engineers, and companies are investing billions of dollars in the search for solutions. That is why, when Tesla claims it has discovered a new path forward, the world pays attention. Tesla's next-generation battery, more than just an improved battery pack. You have probably heard the term solid-state battery mentioned in articles, videos, and industry discussions. While Tesla's latest developments may seem related to that concept, it's important not to assume they are exactly the same thing. To understand the significance of Tesla's approach, we first need to look at the limitations of conventional lithium-ion batteries, the type used in nearly every electric vehicle today. Inside a traditional lithium-ion battery cell, lithium ions move through a liquid substance known as an electrolyte. This movement generates the electrical current that powers the vehicle. The problem is that the liquid electrolyte comes with several limitations. The challenge with traditional lithium-ion batteries is that their liquid electrolyte comes with several drawbacks. It is flammable, gradually deteriorates over time, and becomes less effective when temperatures fluctuate. This is why electric vehicle batteries often perform worse in cold weather, and why their capacity slowly declines after repeated charging and discharging cycles. Solid-state batteries aim to solve these issues by replacing the liquid electrolyte with a solid material, typically a ceramic-based compound or a specialized polymer. In theory, this offers several major advantages: higher energy density, improved safety, longer battery life, and more consistent performance across a wide range of temperatures. While the concept sounds straightforward, turning it into a commercially viable product has challenged the industry for nearly 2 decades. The main obstacle lies in the interface between the solid electrolyte and the battery's electrodes. As the battery undergoes repeated charging and discharging cycles, this contact area can begin to separate, forming tiny cracks that reduce the battery's ability to conduct electricity efficiently over time. Tesla is not the first company to recognize this challenge. However, it may be among the first to develop a practical solution that can be implemented at an industrial scale. Based on patents filed by Tesla in 2024 and 2025, along with reports from industry experts, the company appears to be combining its dry electrode manufacturing process with a new generation of sulfide-based solid electrolyte materials. This approach does more than improve durability. Perhaps most importantly, it could dramatically reduce production costs. Many companies developing solid-state batteries still rely on wet manufacturing processes that require costly chemical solvents and complex production steps. Tesla's dry electrode process eliminates those requirements entirely. The result is a manufacturing system that is simpler, faster, and more cost-efficient. What makes this story even more interesting is that Tesla did not originally invent the dry electrode process. The technology came through its acquisition of Maxwell Technologies in 2019. Since then, Tesla has spent nearly 6 years refining and scaling the technology, transforming it from a promising laboratory concept into a process designed for mass production, the breakthrough. 3 numbers that could change everything. To understand why this technology has attracted so much attention, it helps to focus on 3 key targets Tesla is pursuing and compare them with the capabilities of today's batteries. 1. Energy density, 500 watt-hours per kilogram. Energy density measures how much energy can be stored in a kilogram of battery material. It is one of the most important performance indicators in electric vehicle technology. Today's best lithium-ion batteries typically achieve between 250 and 300 watt-hours per kilogram. Tesla's next-generation solid-state battery is reportedly targeting 500 watt-hours per kilogram, nearly double the current benchmark. In practical terms, That could mean a vehicle traveling twice as far with the same battery weight. Alternatively, manufacturers could achieve the same driving range using a battery pack that weighs only half as much. A lighter battery would improve efficiency, reduce vehicle weight, and lower manufacturing costs. 2. Charging time. 15 minutes. One of the biggest barriers preventing some consumers from switching to electric vehicles is charging time. Tesla aims to reduce this concern dramatically. Because solid-state batteries are less prone to overheating than conventional liquid electrolyte batteries, they can potentially support much faster charging rates. Tesla's goal is to charge a battery from 10% to 90% in approximately 15 minutes using a 350 kilowatt charging source, a power level already available at many Tesla supercharger locations. If achieved, this advancement could make EV charging feel much closer to the convenience of refueling a gasoline vehicle. 3. Battery life. 1 million miles. Perhaps the most impressive target is battery longevity. Most lithium-ion batteries are designed to withstand roughly 500 to 1,000 full charge cycles before their capacity falls to around 80% of the original level. Tesla claims its next-generation battery could endure more than 3,000 charge cycles, translating to over 1 million miles of driving. This level of durability would benefit not only private vehicle owners, but also commercial fleets, delivery trucks, buses, and especially autonomous robo-taxis that are expected to operate nearly around the clock. Technology. Alone is not enough. As impressive as these numbers may be, performance is only part of the equation. A breakthrough technology has little impact if it cannot be manufactured efficiently at large scale. This is where Tesla may hold one of its strongest advantages: gigafactories and the manufacturing advantage. Tesla operates several of the world's most advanced battery manufacturing facilities, including Gigafactory Nevada, one of the largest battery factories by floor area, along with major gigafactories in Texas, Berlin, and Shanghai. These facilities are more than production plants. They function as large-scale industrial laboratories where Tesla continuously tests, improves, and optimizes manufacturing processes. The company's dry electrode production method offers another significant advantage. Unlike traditional battery manufacturing, it does not require expensive cleanroom environments or large amounts of hazardous chemical solvents. As a result, scaling production becomes more efficient and cost-effective. Instead of costs rising proportionally with output, Tesla's manufacturing model has the potential to become increasingly efficient as production volumes grow, creating a powerful advantage in the race to bring next-generation batteries to market. Instead, manufacturing efficiency improves as companies gain experience and refine their processes over time. Elon Musk has often said that designing a product is only half the challenge. The real difficulty lies in designing the factory that produces it. In Tesla's case, the company has spent nearly 6 years developing both the battery technology and the manufacturing system simultaneously. According to several industry analysts, if Tesla can achieve its target battery cost of around $60 per kilowatt-hour for its next-generation solid-state batteries, compared to the current industry average of roughly $100 to $120 per kilowatt-hour for advanced lithium-ion batteries, the production cost of vehicles such as the Model 3 and Model Y could drop below $30,000 while still maintaining healthy profit margins. Reaching that price point has become one of the most important goals for the entire electric vehicle industry. At this stage, many people naturally ask, if the potential benefits are so significant, why hasn't anyone accomplished this already? The simple answer is that many companies have tried, and many have struggled. The challenges Tesla still faces. While Tesla's progress is impressive, there are still major obstacles standing between promising technology and large-scale commercial success. Challenge number 1. Scaling the dry electrode process. One of Tesla's biggest hurdles remains its dry electrode manufacturing technology. Although the process has shown tremendous promise, scaling it from small pilot projects to full industrial production has proven more difficult than initially expected. Tesla has acknowledged in multiple quarterly reports that increasing production capacity has taken longer than planned. For example, the company originally targeted producing 100 gigawatt-hours of next-generation batteries by the end of 2023, but actual output fell well short of that goal. This is not the first time Tesla has faced delays in meeting ambitious production targets. Challenge number 2. Moisture sensitivity of sulfide electrolytes. Another significant challenge involves the sulfide-based solid electrolytes believed to be part of Tesla's battery design. These materials are highly sensitive to moisture. Even limited exposure to normal air can damage their structure and performance. As a result, manufacturing requires extremely dry environments, which are costly to build and difficult to maintain on a massive industrial scale. Challenge number 3. The dendrite issue. One of the oldest and most persistent challenges in solid-state battery development is the formation of dendrites. Dendrites are tiny, metallic structures that can develop inside batteries after repeated charging and discharging cycles. Over time, they can grow through the solid electrolyte layer, creating internal short circuits. In severe cases, this can lead to battery failure or safety risks. Researchers have made substantial progress in reducing dendrite formation, but no company has completely eliminated the problem. Challenge number 4. Performance in extreme cold. Although solid-state batteries offer many advantages over conventional lithium-ion batteries, they are not immune to performance losses in extremely cold conditions. For consumers living in regions where winter temperatures regularly fall below -20 degrees Celsius, battery efficiency and charging performance can still be affected. Addressing this issue remains an important priority for battery developers. What are BYD, Toyota, and other industry leaders doing? When discussing the global EV race, it is impossible to ignore BYD. The company achieved a major milestone in 2023 when it sold more electric vehicles than Tesla for the first time in history. And it wasn't a narrow victory. BYD delivered more than 1.5 million electric vehicles in a single year, establishing itself as one of the world's most influential EV manufacturers. What makes BYD especially formidable is that it is far more than a car company. It also manufactures its own batteries, including the well-known Blade battery, which is based on lithium iron phosphate, LFP, chemistry. The Blade battery addresses two of the industry's most important concerns. The first is safety. Compared with many traditional lithium-ion battery designs, it is significantly more resistant to thermal runaway and fire risks. The second is cost. Because LFP batteries do not require expensive materials such as cobalt or nickel, they can be produced at a lower cost. However, BYD is not relying solely on its current technology. Toward the end of 2024, the company announced plans to develop its own solid-state batteries, with commercialization targeted around 2027. At the same time, BYD has been investing heavily in ultra-fast charging systems. One of its most ambitious projects is a 1,000-volt charging platform designed to add approximately 400 kilometers of driving range in just 5 minutes. Yes, 5 minutes. If that performance can be delivered consistently in real-world conditions, it would represent one of the fastest charging technologies ever introduced to the market. Who is leading the EV race? The answer depends entirely on how success is measured. If the focus is current vehicle sales, BYD holds the advantage. If charging infrastructure is the benchmark, Tesla remains ahead. Its supercharger network continues to be one of the largest, most reliable, and most widely used fast-charging networks in North America. If software integration and artificial intelligence capabilities are the criteria, Tesla maintains a strong lead. Its autopilot and full self-driving platforms remain among the most advanced driver assistance systems available today. When it comes to manufacturing costs in the budget and mid-range segments, BYD currently enjoys a significant advantage due to its efficient production model and battery strategy. However, if the measurement is future battery technology, the outcome remains uncertain. That brings us to another major player that is often overlooked in discussions about the EV race: Toyota. Toyota's quiet push into solid-state batteries. Toyota has invested tens of billions of dollars into next-generation battery research and has repeatedly stated that it expects to launch commercial vehicles equipped with solid-state batteries between 2027 and 2028. Unlike many newer EV-focused companies, Toyota brings decades of manufacturing expertise, global supply chain experience, and one of the largest dealership networks in the world. At the same time, the company is frequently criticized for moving more cautiously and slowly toward full electrification compared to competitors like Tesla and BYD. Whether Toyota's patient approach proves to be a strength or a weakness remains one of the biggest questions in the future of the automotive industry. Tesla is not the only company pushing the boundaries of battery technology. Panasonic, Tesla's longtime battery partner, is also moving aggressively in this space. The company is constructing a new battery manufacturing facility in Kansas, with plans to begin supplying next-generation batteries to Tesla starting in 2026. Another company attracting significant attention is QuantumScape, a startup backed by Volkswagen. It has become one of the most closely watched players in the solid-state battery sector. However, like many others in the industry, QuantumScape continues to face the difficult challenge of scaling its technology from laboratory success to mass production. Meanwhile, South Korea's battery giants, Samsung SDI and LG Energy Solution, are investing heavily in their own solid-state battery programs. Both companies already supply batteries to major global automakers and are working to secure their position in the next generation of electric vehicle technology. This is not a race between just two companies. It is a global marathon involving some of the world's largest automakers, battery manufacturers, and technology firms, all competing on a track where the rules continue to evolve almost every day. Could this technology really change the future? That brings us to the biggest question of all. If Tesla succeeds, how different could the world become? Imagine a realistic scenario set in 2028. Tesla has successfully commercialized its next-generation solid-state battery technology on a large scale. Battery costs have fallen to between $60 and $70 per kilowatt-hour. The base version of the Model 3 sells for around $27,000 before taxes. Vehicles can travel approximately 500 miles on a single charge, and recharging takes less than 20 minutes. What happens next? For consumers, many of the traditional barriers to EV adoption begin to disappear. Electric vehicles become directly competitive with gasoline-powered cars on price. Long driving ranges largely eliminate concerns about running out of power, and charging times become short enough that they no longer feel like a major inconvenience. If this scenario becomes reality, analysts believe EV adoption could accelerate dramatically. Some forecasts suggest that electric vehicles could account for more than 60% of new vehicle sales in the United States by 2030, significantly higher than many current projections. The impact on the oil industry. The effects would extend far beyond the automotive market. Transportation currently represents a major portion of global oil consumption through gasoline and diesel demand. As electric vehicles become more affordable and practical, demand for traditional fuels could begin declining at a pace that would be difficult to reverse. Many major energy companies are already preparing for this possibility. Industry experts increasingly believe that peak oil demand, the point at which global oil consumption reaches its highest level, could arrive much sooner than previously expected. The power grid challenge. A massive increase in electric vehicle adoption would also place significant pressure on electrical grids. Millions of vehicles charging simultaneously would require substantial investments in energy infrastructure and grid modernization. However, this challenge also presents a unique opportunity. Future EVs could serve as mobile energy storage systems through vehicle-to-grid technology, allowing cars to return electricity to the grid during periods of high demand. Tesla has already tested versions of this concept in Australia and several European markets, demonstrating how EVs could become part of a more flexible and resilient energy system. The response from China. If Tesla gains a significant lead in solid-state battery technology, Chinese automakers could face increased competitive pressure. Many Chinese manufacturers currently enjoy advantages in production efficiency and lower costs, but a major technological breakthrough could shift the balance. At the same time, it would be unwise to underestimate China's ability to respond. The country invests billions of dollars annually in battery research and development and remains one of the world's largest centers for innovation in energy storage technology. Any technological lead gained by competitors would likely be challenged quickly. The impact on jobs and industry. A transition to solid-state batteries would also reshape the labor market. Manufacturing these batteries requires different production methods and specialized expertise compared to traditional lithium-ion batteries. This shift could create new opportunities for engineers, technicians, and highly skilled manufacturing workers. At the same time, it may require portions of the existing battery workforce to learn new skills and adapt to changing technologies. As with many industrial transitions, the benefits and challenges would arrive together. The rise of robotaxis. Perhaps one of the most important and least discussed effects of next-generation batteries involves autonomous transportation. Elon Musk has repeatedly stated that Tesla's long-term vision extends beyond simply selling cars. The company aims to operate large fleets of autonomous robotaxis. For that vision to work economically, vehicles must remain reliable for extremely long periods of time. A battery capable of lasting 1 million miles changes the equation dramatically. Instead of requiring expensive battery replacements, a robotaxi could operate continuously for years while maintaining strong performance. That makes the business model behind autonomous transportation far more practical than it is today. The bigger picture. We've covered a long journey, from the limitations of traditional lithium-ion batteries to Tesla's dry electrode manufacturing process, from ambitious targets for energy density and battery lifespan to the significant technical challenges that still remain. But what is the most important takeaway? It is not simply that Tesla may be building a better battery. The real significance is that if Tesla succeeds, it could fundamentally reshape the competitive landscape of the automotive industry. Cost, performance, and convenience, the three factors that drive consumer decisions, could all improve at the same time. And when that happens, market dynamics can change faster than anyone expects. The major players understand this. Tesla understands it. BYD understands it. Volkswagen understands it. Toyota understands it. That is why companies across the world are investing billions of dollars into the race for next-generation batteries. They are not doing it merely because they want to lead the future. They are doing it because staying competitive may depend on it. The reality check. At the same time, there are still many unanswered questions. Tesla has a history of making ambitious promises and missing timelines. From the Cybertruck and the next-generation Roadster to the solar roof and full self-driving technology, delays have often been part of the story. There is no guarantee that Tesla's solid-state battery program will reach commercialization on schedule. There is also no guarantee that costs will fall quickly enough to create a decisive advantage before competitors such as BYD, Toyota, or others achieve similar breakthroughs. Beyond technology, the future of electric vehicles depends on many factors outside the control of any single company. Government policies, trade regulations, raw material prices, charging infrastructure expansion, and consumer behavior will all play important roles in determining how quickly the industry evolves. The race has already started. Despite the uncertainties, one thing is becoming increasingly clear. The race has begun, and there is no turning back. The question is no longer whether electric vehicles will eventually replace gasoline-powered cars. The more important questions are, who will develop the next generation of battery technology? Who will control the most valuable innovations in the electric vehicle ecosystem? And for consumers making decisions that could affect them for the next decade or more, which company deserves their confidence? No single video can provide a definitive answer, but these are questions worth thinking about because the decisions made today will shape the future of transportation for years to come. Final thoughts. What do you think? Will Tesla successfully deliver on its solid-state battery ambitions? Or will competitors such as BYD, Toyota, or another unexpected challenger cross the finish line first? Share your thoughts and opinions in the comments. Every perspective adds to the conversation, and it's always interesting to hear how others see the future unfolding. If you found this analysis useful, consider supporting the channel with a like and sharing it with others who are interested in the future of technology and electric vehicles. And if you haven't subscribed yet, now is a great time. The battery revolution is still unfolding, and there are many more developments ahead that we'll continue to explore together. Thanks for watching, and I'll see you in the next video.